All right, let's talk about these word problems now. So remember with word problems, our first step is not to start to solve it. It's to set it up. So we want to always define the variable, set up an equation, solve the equation, answer in a complete sentence. And what would you say step 5 is? Check. Very good. Okay, so the length of a rectangle, well, right away, when I see that they're talking about a rectangle, I'm going to draw a rectangle. Just to save myself space, we'll just use this rectangle I drew right up here. The length of the rectangle is 5 inches more than twice the width. So we start by defining the variable. If I say that I'm going to use let W be the width, let the width equal W. Okay, then the length, I want to write an expression using W. I don't want to have two variables because, as you will find out soon enough, we cannot solve an equation that has more than one variable. So what would I do to write an expression? What do I do to the width to give me the length? Yes, 2, it's twice as much, right? Twice the width. And then what else? Plus 5. And notice I have 2 of those lengths, 2W plus 5. So now if I want to find the dimensions of the rectangle and I know that the perimeter is 76 inches, who can write me an equation that would model this situation? How many lengths and how many widths do I have? Yeah. I'll just do 2W plus 5, right? Because that's 2 lengths equals what? 76. That's the perimeter. So when you were just telling me 4W plus 10, you actually added those together and you took 2 of them. But I'm just modeling how you could set it up first, and then you might use the distributive property here when you start to solve. 2W plus 4W plus 10 equals 76. Does everybody see? One of the most common mistakes that students make with this problem is that they will only add 2 of the sides. They forget all 4 sides. So that's where he got the 4W plus 10, because he had 2 of those lengths. Any questions on the setup so far? 2 sides, 2 lengths, and 2 widths. Did you have a question? Oh. Oh, okay. And then what about, how would you solve it? What would you do next? Add like terms, and so what do you get? Yep. Plus 10 equals 76, and now what? Subtract 10, good, from both sides. 6W equals 66, good. And now, what do you get? Divide both sides by 6, and W equals 11. So notice this is asking me for the dimensions. We're going to answer the question always in a sentence. The width is what? 11 inches, and I like that you included units. What's the length? Well, it would be 2 times 11 plus 5, and that's 22 plus 5, which is 27 inches. The width and the length. The dimensions is both. And then the last step, what do you think we should do? Once we get an answer, we want to know that answer is correct. So what should we do? Check. And so how do we check it? Yeah. I would even, in a word problem, I wouldn't even worry anymore about my equation. I want to know, is the perimeter of this rectangle, if this is 11 and the length is 27, I want to know what's the perimeter of that rectangle. So I would go 27 times 2, since I have 2 lengths, and you might even write it on both sides, plus 2 times 11, and is that equal to 76? 2 times 50, I already did the math, 54. 2 times 27 is 54, plus 22 is 76, and that's true that 76 equals 76. So that check confirms that we know we got the right answer. Okay. Any questions on that one? Let's go on to the next two problems. So these problems are dealing with a formula that you were originally manipulating, and that was the distance equals rate times time. So D equals rate times time. Let's think about this in our real lives. If you were driving on the freeway at 60 miles per hour, and you did that for 2 hours, how long would you have, how far would you have driven? You would have driven 120 miles, right? Yeah. So that's where we get this idea. If I take my rate, which is 60 miles per hour, and my time, which is 2 hours, my total distance is 120 miles. Okay? Miles per hour, hour. And we get the distance. All right, I'm just going over that so that you can have an idea for the next one. So again, we're going to use our same problem-solving setup, defining the variables. Okay, Pat drove 3 hours to attend a meeting. On the return trip, his speed was 10 miles per hour less, and it took the trip, and the trip took 4 hours. What was his speed each way? So let's think about this for a minute, and you might even draw a picture. Here's Pat, and Pat's going to the meeting. Okay, over here's the meeting. It took 3 hours. Then, when Pat went back, it took 4 hours. Now, I don't know how fast Pat drove, so I might use a variable because I do know the time, right? But I don't know the rate. So we could say R is the rate to the meeting. If I go 3 times the rate, won't I find the distance? If I do that? And I could actually in your problems, you actually end up having a table. So we could say this is to meeting and then home. But drawing a picture can be helpful too. Distance, this is a D, equals the rate times the time. We know the time was 3 hours to go to the meeting. We don't know the rate, so that's where we're using a variable R. The distance is going to be the rate times the time. So 3R is how far he went. They didn't tell me anything about the distance. Now, to go home, how long did it take him to go home? It was 4 hours to go home. What was his rate? Do I know anything about the rate? Do I know anything in relation to the rate that it took him to get there? I know that his speed was 10 miles per hour less. So whatever this rate was, what would I do? How would be an expression for 10 miles per hour less than that? R minus 10. So here I have 4 R minus 10. That would give me his distance because my rate times my time is equal to my distance. Now let's look. Did he make any detours, or what's the distance? The distance to the meeting and the distance home, isn't it the same? So that means these two distances, 3R is equal to 4 times R minus 10. Do you see that? The distances are equal. Since this distance from here to here is the same as going back and forth, right? I use the letter P, but this is really Pat. Pat to the meeting. So you kind of acting it out, organizing into a table can be helpful. And then since we know the distances are equal, we can set the rate times the time equal to each other. Does that kind of make sense how that's set up? Well, we're going to try another one that's quite similar, okay? So now that we have it set up, we could solve it, right? So what would you do to solve this? Distribute the 4, so we have 3r equals 4r minus what? 40. And what would you do next to solve for r? Subtract 4r, because we want to get the 4r away from the negative 40. So we have negative r equals negative 40. So what does positive r equal? 40, right? So the speed to the meeting was 40 miles per hour. What's the speed home? And how'd you get 30? Yes, the speed home was 30 miles per hour. I wonder if we could figure out the distance from Pat's home, or wherever Pat was. I don't know if he was home. He or she was home. Can we figure out how far away Pat was from the meeting? Well, that would be like our check, right? If Pat drove for 3 hours at 40 miles per hour, the distance would be 3 times 40, which is 120. And the distance home is 30 times the 4 hours. That was the rate times the time, which is also 120 miles. It just is a coincidence that it's 120 miles, and originally I was talking about 120 miles. Okay. All right, let's try another one. I know these can be tricky, so, thinking about drawing a picture to try and act it out could be really helpful as well. Let's look at problem letter C, and this one is involving Martin. So, at 4 p.m., Martin leaves on bus from Albany, Oregon to Seattle, Washington at a rate of 40 miles per hour. This time I have the rate. An hour later, John leaves Seattle for Albany driving at a rate of 60 miles per hour. Seattle and Albany are 240 miles apart. At what time of day will Martin and John pass each other on I-5? I would really need a picture for this. So I'm going to draw a picture. I'm going to just take a little piece of paper here and let's draw a picture. So we know here's Seattle. And then down here is Albany. So we're just going to fill in any information that we have. How far away are they? 240 miles apart. So we know something, that's the distance. Okay. Now, what happened? At 4 p.m., Martin is driving this way. So this is Martin, and Martin is going 40 miles per hour, mph, right? An hour later, John, oops, did I get it? Oh, I got it backwards, didn't I? Oops, you guys didn't correct me. Okay, actually, Martin was going from Albany to Seattle. So this is Martin, and he's going 40 miles per hour. And then John is leaving from Seattle and driving much faster at 60 miles per hour. John, 60 miles per hour. We want to know at what time are they going to meet, right? So let's think about this in terms of distance equals rate times time. What is the unknown? What is the variable? So we have John and we have Martin. And I probably should have done it in the reverse order. We have the distance equals the rate times the time. Okay, so I'm just making a really haphazard table here. So, what is the rate of John? Well, isn't it 60 miles per hour? And what is the rate of Martin? So we can just fill in anything we know. Anything that you know from the word problem, fill it into your table. Both of your problems that you have on your activity are set up in a table. Okay, do we know anything about the time? Isn't that what we're trying to find out? So our variable then is the time, isn't it? So we know that Martin starts at is driving for a certain amount of time. Let's just call his time t. How much time compared to Martin is John driving? John's trying to catch up. So what do you know about John's time? He left an hour later. So if Martin is driving for 3 hours, how long is John driving for? 2, because it would be t minus 1, right? Okay, so t minus 1, this is their rate times the time gives me the distance. So the rate times the time, that's 60 times t minus 1. And then what's the distance Martin has traveled? Well, it depends on how long he's been driving, right? So his distance is 40t. Okay, now they're going to meet someplace in the middle. How far are their distances going to be equal to each other? No, when they meet, how far have they gone together total? The total distance is, does anybody know? From Seattle to Albany? Well, it says from the problem, 240 miles, right? So if we add up their distances together, you get 240 miles. And don't worry, I think you should know that while I'm setting this up, I'm also secretly panicking because I'm like, am I getting this right? Does this even make any sense? So I just need you to know that you're not alone if you're like, you're looking at a word problem and you're panicking, okay? But if you're taking it, just take it step by step. Who can tell me what they think the equation is? Well, John's going to go a certain amount of distance. Martin's going to go a certain amount of distance. If we add their two distances together, we get 240. So here's John plus Martin equals 240 because they're going the whole way. We said John was 60 plus t minus 1, and we said Martin was 40t equals 240. Does that equation seem reasonable? This rate times his time will tell us how far he went. This rate times his time will tell us how far he went. If they're meeting halfway, their total distance will be 240. So with these, know that they're challenging and you can do them. You just have to take them step by step. Organizing it, drawing a picture, all of these things could be helpful. Okay? And now what would you do to solve it? 60t minus 60, right? He's losing an hour of the same distance, right? He's going an hour less, so that's where we get the minus 60, plus 40t equals 240. What would you do next to solve? You can tell me, shout it out, shout it out. I would add my like terms, 100t. I would add 60 to both sides and get 300. And what would you do next? And I get t equals 3. So t equals 3, what does that tell me? Yes, Martin took 3 hours. Exactly. It took Martin 3 hours. And John, how long was John driving for? 2 hours to meet. That's what happens when you leave an hour later, you have to drive a lot faster to catch up, don't you? And let's see, where do they meet? How far do they each go? Well, if Martin was driving for 3 hours at 40 miles per hour, 3 times 40 miles per hour, that means he's gone 120 miles. Oh, why? Everything is 120 miles, I guess. And then if John was driving for 2 hours times 60 miles, how far did he go? Also 120 miles, because when in doubt, the answer is 120 miles. How far is it from Portland to Eugene? Probably 120 miles. I don't know. Okay, so, and then if we add their two distances together, right, how much is the total distance from Seattle to Albany? 240 miles total. So this is like our check. Here's our sentence. And know that if you're feeling like when you read the word problem and you're panicking, that I do the same thing, but you still can solve it. Okay, just make sure it makes sense to you. Draw a picture, make sense of it as much as possible. Start with defining your variable. What's the thing you don't know? What's the thing you do know? Question, yes. Okay. Okay. I see what you're doing. Yes. So I get what you're saying, and that is a really good point. So you could, that is very true. With all of these word problems, you could probably reason them out without using algebra. So your point is this. If I say, okay, here's Martin, here's John. He went 40 miles, 80 miles, 120, 160, blah, 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 right? And then, 180, okay. 160, okay. And then John is like 60, 120, and then you're like, well, I get what you're saying, and in a way, yes, of course you could do that to problem solve in real life. This class is called algebra, so that's why we're using these problems to help us write algebraic equations. Yeah, so even though a lot of these problems you could just figure out in your head or use other problem solving, and I'm not saying there's anything wrong with that. In real life, that's great. But in algebra, we are also trying to use the algebra. So let's try and practice with using the variables, setting it up. Because notice in the directions for all of these, it says define a variable, set up an equation, solve the equation, answer in a complete sentence. If we do a table, you are still problem solving, but you're just not using a formal algebra setup. That's all. But good question. Nice try.